Hi everybody, my name is Massimo Banzi and I'm one of the co-founders of Arduino. Welcome to the second video in a series of videos about the Arduino robot. So in this video, David Quartielles and Kyung Yang are going to show you how to run the logo example on the robot, how to calibrate the wheels to make sure the robot goes as straight as possible, and how to use a remote control to control the robot itself. I hope you will enjoy it, and take it away, David.
Hello, this is David.
This is Xun.
We're here today to continue on the video series about the Arduino robot. Remember that the Arduino robot is an omnidirectional platform, which means it can move in any direction, can move forwards and backwards and turn by making the wheels turn in opposite directions at the same time. Today we're going to see how to first calibrate the robot to make in a perfect straight line. Second, make a program that will help you program movements on the robot directly from the keyboard on it. And third, check how to control the robot from an infrared remote control. Jun?
Yeah. So let's first have a look how to calibrate the robot. One thing very important about the robotics is that no two motors are the same. So even if you ask this robot to go forward at the same speed for left and right, it's very likely that it won't be going a straight line. This is a point when we need to do the calibration. And fortunately, we have a feature on the firmware that allows you to calibrate the robot with this potentiometer on the motor board. You just need to change the position of the potentiometer.
In order to check whether the wheel calibration is right or wrong, we have created a software example for you, which is example number 6, called wheel calibration, that will let you calibrate by hand the robot's wheels so that it moves straight over a line. So we will interact both with the knob here by following the instructions on the screen, as well as using a screwdriver. You have to interact with the trimmer down here. But first, let's upload the software on the robot to start interacting with it. Sure. I will open the example on Arduino's IDE. It's in the folder for the robot control. Here, robot control, explore, example number 6, wheel calibration. This example is very simple. Like all the other robot examples, it first calls the Arduino robot library, and then it calls something called the robot text manager library. It's because we are handling a lot of different strings in the code, and in order to show them on the screen properly, we just store them on the string here. And then in setup, we start up the robot, start up the screen, and start reading the SD card where we store all the different images for the instructions for the robot. And in the loop, you see that we do only two things. First, we check the speed of the robot, that's taken straight from the knob. And then we write that information to the motors so that we see whether the robot is moving straight or not. Then we take the calibration value from the trim controller, the trimmer that is on the bottom board, and we finally write up the value on the robot screen. In this way, you can take notice of this value and use it for future reference when you want to recalibrate your robot in the future.
Okay, let's first find a small screwdriver that will be necessary for calibrating the robot. And as we have talked about before, that the USB cable actually disengages the motors, so you have to unplug it first, otherwise the motors won't run. Yeah. Okay, now let's turn on the robot. You can see the robot is running very fast. You can adjust the speed by turning this potentiometer. Let's get it slow a bit. And then put it on a flat surface. See if it goes a straight line. And you can see that it's very uneven, turning to the right direction a lot. And you can see there's a value on the screen showing 15, which is a value read from the trim on the bottom, which we can use to calibrate it. Let's get it to -5 and also speed it up a bit. Looks much better. But it's still turning around a little bit. So this time let's turn the value back to say 2. And you can further calibrate it by using a ruler to help it to make sure that it goes a straight line. But now we are going to stop here.
We will now continue with our next example, where we're going to see how to control the robot's movements by programming them straight from the robot's keyboard. For doing that, we're going to use an example that is called LOGO. You might remember the LOGO programming language from back in the days. Some of you might not even know what LOGO is. The idea behind LOGO consists in having a virtual turtle that is on your computer screen, and you give commands to it like move forward, turn to the right, turn to the left, and that will make the virtual turtle move and will leave a trace on the screen. Well, we're going to implement a real-life version of the virtual turtle using the Arduino robot. I will just tell it to move forward by pressing the button forward, turn to the right or left or backwards, and then tell it to execute the list of commands by pressing the central button, and it will just reproduce the movements we program. We have that as an example in our IDE. So we turn on our computer again, get the cable. We will continue programming our robot now. We'll connect the cable to the robot, and then we just open the example called LOGO. Using our examples, robot control, explore, LOGO. Here's the first example for the Arduino robots library. Here you see, like in every example, first of all, we call the Arduino robot library. We use an array called commands, where we're going to be storing all the possible commands we'll push in the robot. It has a maximum length of 20 commands. I think it's quite a lot of commands anyway. Then start the robot, start the screen, start the SD card, and let's take a look at what it does in the loop. In the loop, it's going to be calling this function called add commands. You can take a look at it later, but it's just going to be reading the commands from the keyboard and storing them in the array. So when you press the white button, you will be calling them one by one, executing them in a row. So I make sure I have the right board, Arduino robot control, and the right serial port. And I upload the code to the robot. Once the robot is programmed, I can completely remove the computer from the scene and pass it over to Jun that will explain you how the program works again.
Yeah. So this time let's turn on the robot again. And this program asks you to press the buttons for up, down, left and right a few times to record the movements you want it to do. Say, let's first start with something simple. First go forward and then turn right. And now if you press the middle button, it's going to start moving. So let's put it on the table first. Okay. Start. And now it's done.
I will now send it back to Jun. So I'm going to tell the robot to go forward, and then turn 1, 2, 3, 4 times, and run. It's going to fall off the scene. There you go. Jun, get ready to stop it. We're going to learn now how to use infrared remote control like this one. It's a universal remote control to control the robot on distance. There is an example that you can use for working with the robot using a remote control. You should know that not all remote controls work the same way. There is one clear thing, that remote controls use a chip like this one. This is an infrared receiver like the one you can have on your TV or your stereo or other things controlled by infrared home. And this contains both an infrared receiver and an infrared amplifier, so it makes it very easy to connect it directly to a 5 volts microchip like the one that commands the Arduino robot and read data from it. So in this case, we're going to use a remote control like this one, but not all remote controls work the same. So we recommend you explore the Arduino expansion kit for the robot that will come with both a sensor like this and a remote control that are compatible with the software that comes with the robot. You could of course enhance the robot software to make it work with other infrared controllers. So first thing, you will need to connect it, and Jun has prepared a cable to easily connect the infrared sensor to the robot. June?
Yeah. So let's first connect the infrared receiver to the cable. It's just like a normal component, so this platform is very extendable. It's just connected to the port D2 as the sketch says. And it's good that we tape it in a good position, so it will not move around a lot.
Okay, let's now program the robot. As usual, plug it to the computer, and we just look for the right example on the IDE. In this case, as I said, is the one called remote control, which is example number 8. You see that first, you will see that this says that this example is experimental. It's just because you might be willing to use a different remote control. That's why we talk about using a universal remote control, because you can program it to operate in different ways, and it will definitely work with the sensor. So once you've opened the example, you will see that first we are working with a contribution by Ken Sharif that contributed to the Arduino code base by adding infrared remote control library. June worked trimming it down so it fits for the robot. Then we include the Arduino robot library, and we define a series of infrared commands. This is how you read a command as a series of numbers. You see that they are slightly different, each one of them, so they represent different commands on the remote control. So we're going to be reading upwards, downwards, left, and right. You will also see that there is a couple of places where you can change this code. For example, timeout is a variable that allows you distinguishing how often you are going to be reading the button. Then after the classic initialization calls like start the robot, start the TFT screen, start the SD card, you will see that the loop is a very, very small program where we're essentially just checking whether there was an IR remote control command received. And if it's received, we'll process different commands. The process result function is just deciding whether you're going to send the motor forward, backward, turn left, or turn right. This -1 and +1 that you see here are just multiplied by the multiplication factor so that the robot doesn't move too quick. So this 128 is setting up the speed of movement for the robot. If you want the robot to go faster, you could change this to 255 and it will just go really, really quick. So I just program the robot with this code and check it out for real. The robot's now programmed, and I pass it over to June. I will show you how it works.
Now let's turn on the robot, put it on a flat surface. Now we can control it with the remote control. So let's turn back, and yeah, let's go forward, go back. Oh. Yeah.
And you see the robot is moving as long as you press the button on the remote control. So that's basically the idea, and we're quantifying the time in fourths of a second. So if you change the timeout variable in the code, you may make the movements last in multiple factors of 1/4 of a second. It's time to call for the day, but before we hand over to Massimo, we should probably recap what we did today. June?
Yeah, so in today's video, we showed you how to calibrate the robot wheels, how to run the LOGO example, and how to control it with a remote control.
Okay, that's all from Sweden. Hej då!
Hej då!
Okay, thank you, David. That was great. So I hope you enjoyed the video, and please join us at the next videos in the series. Thank you.